Hello, this is Mr. Henry, and welcome to lesson 2.7. Today's lesson is talking about square roots. How do we find square roots? How do we estimate square roots? And a little bit of other stuff as well. So, the essential question says, how do I find square roots and compare real numbers? And we got a couple little get the goofs here, so let's check to see how we're doing. The first one says find the square of a number. So when you square a number, you take the number times by itself. So 3 squared would be 3 times 3, which is not 6, it's 9. 7 squared would be 7 times 7, which is 49. And 14 squared, which is 14 times 14, it's not 200. It's probably like it's going to end in a 6. I know that. Let's see. 14 times 14. That's 16. That's 4 plus 1 is 5. Drop down. Add a 0. 4, 1, 1, 9, 6. 196 is 14 squared. Okay? So those are squaring the numbers. The second and third get the goofs here are seeing which numbers are bigger. Here we have 3.5, here we have 3/5. We want to know which of those is the bigger number. The honest, easiest way to do these problems is to change your fractions into decimals. If you can change your fractions into decimals, you're going to have a much easier time with this problem. So to change this 3/5 into a decimal, you have to do a long division. So you put the top number on the inside, bottom number on the outside, add a decimal, add a 0, and then go to town. Now, 5 goes into 3 0 times, 5 goes into 30 6 times. Now, I actually don't even need to go any farther than this, because this number is 3.5, this one's 0.6, 3.5 is bigger than 0.6, whatever. It doesn't matter what else I'd get over here. 3 point is bigger than 0 point. Okay? Letter number 3 here, so this one's wrong. Number 3. 5/6 and 21 over 25. So let's see. Top number goes on the inside, add a decimal, couple zeros. Top number goes on the inside, add a decimal, couple zeros, and let's see. Okay. 6 goes into 5, 0. 6 goes into 50. Not quite 10 times. 9 times would be 9 times 6 is 54. That's too big. 8 times 6 is 48. So 8. 48 subtract 2, 0. Now, if this is bigger or smaller than 8, I know which one the answer is. So let's check. 25 goes into 21 0 times. 25 goes into 210. Let's see. 25 goes into 4 times. It would go into 208 times. So it would be 8 as well. 25 times 8 is 200. Subtract, you get 10. Bring down. Ooh, this one's going to be exactly 4. 25 goes to 104 times. Okay, so now I got to figure out what this is. 6 goes into 20. 3 times. 3 times 6 is 18. So 0.83 or 0.84, 84 is bigger. This is the bigger number. Okay, so that's a little bit of changing fractions to decimals, doing a long division. That is how you compare fractions. Change them into decimals. That is the easiest way, especially if you are allowed to use a calculator. You just hit 21 divide 25, boom, decimal. Okay, so we got some vocab here. The first word is square root. The square root is the opposite of squaring a number. You know in math how everything has opposites, like adding and subtracting are opposites. Multiply and divide are opposites. Well, squaring something, square, and square root are opposites. Radicand. The radicand is the number under that symbol. So the radicand, if I had like a 25 here, 25 would be the radicand. I'll be honest, that's probably the only time in this entire lesson you're going to hear me say the word radicand. I'm never going to say it again. I'm going to say the square root of 25. Perfect square. The perfect square is a number that if you take the square root of it, you get a whole number, like 25. If I take the square root of 25, you'll find out here shortly, that gives you the answer of 5. Or if I take the square root of 81, I get 9. So these 25 and 81 are considered perfect squares because if I take the square root of it, I get a whole number. Got 2 more. All right. Irrational number. An irrational number is a number that cannot be written as a fraction. And when we get down to it, we'll talk about it a little bit more, but let me give you a little preview. There's 2 ways a number can be written as a fraction. It can be written as a fraction if you can, first off, if it is a fraction, it's rational. So these numbers that cannot be written as fractions, meaning they are decimals that don't stop and don't repeat. So, for example, one of the most common irrational numbers you can think of is pi. 3.14159265358 blah 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 blah. Scientists have actually pulled up computers that have run day and night for years, and they've found literally billions of digits of pi. It does not stop, and it does not have a repeating pattern. You won't see, like, if you divide 23 divided by 99, you're going to get 0.232323, and that same pattern is going to repeat over and over again. Nothing like that happens in pi. So pi is considered an irrational number. So if you cannot write it as a fraction, if it is a decimal that does not stop and does not repeat, it's irrational. And the last word here is a real number, which is everything. Almost every number you know of are real numbers. They are fractions, they are decimals, they're positives, they're negatives, they're even these irrational numbers are considered real numbers. So pretty much every number you're going to see until you get to a high-level math like pre-calculus or calculus, every number is pretty much going to be a real number. Okay, so let's do some square rooting. So, the square root of 9. To find the square root of 9, what we have to do is we have to figure out what number times by itself gives us 9. So you're going through the times tables in your head. 1 times 1, 2 times 2, 3 times 3. 3 times 3 works. So the square root of 9 is 3. Because it was, 9 is a 3 squared, and squaring something and square rooting something are opposites, so the answer is 3. Letter B. What number times by itself gives you 49? So 3 is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49. Aha! 7. 7 times 7 is 49. So the square root of 49 is 7. Now, we have this plus minus symbol out front here. What that really means is it could be a positive 7 or a negative 7. Here's one thing I want you to do. On your note sheet, below these examples, below A, B, C, D, E, you have some space on your paper. I'm going to have you do something that's going to help you out for the rest of this lesson and even a little bit into the future. We're going to write out the perfect squares and their square roots. So watch this. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3, 3 squared, is 9. 4 squared is 16. I would like you to do the rest of them up to like 12 or 13. Go ahead and do that. I'm going to be doing it as well. And 13 squared is 169. All right, so I have everything up to 13. So this is going to help you out because now you have something to look back on. If you really don't know the square root of something, you can look back at this and go, okay, let's see. So for letter C, 36. Now you can look up at your chart and go, okay, 36, the square root is 6 because 36 is 6 squared. So square root is 6. And then we need our negative sign on the outside. Now, I'm going to have you do 2 more problems. You can look at your chart. Find the square root of 121 and the square root of 4. Go ahead, pause the video, do them right now. And you should be done. I mean, you probably don't even need to pause the video. Square root of 121, you look up, is 11. And this plus or minus the square root of 4, well, the square root of 4 is 2 because 2 times 2 is 4. So you get plus or minus 2. Pretty simple. Now the next thing we're going to do is we're going to approximate a square root. What that means is what happens if you don't get exactly like 25 or 36 or 49? What if you get something in between? Like square root of 15, for example. 15 was not one of those numbers on our chart. So what we do is we basically say, okay, well, what are the perfect squares around 15? Well, we know the square root of 9 is 3. The square root of 16 is 4. Where does 15 fit in between here? Well, 15 is closer to 16 than it is to 9. So we would say that the answer to this is about 4. The square root of 15 is about 4. It's closer to 4 than it is to 3. So we'd say it's just about 4. Same thing for letter B. What are the perfect squares around 55? Look at your chart. We have square root of 49 less than it, square root of 64 more than it, that's 7, that's 8. So where does 55 come into play here? Well, it's about 6 away from here, about 9 away from there, so we'd say it's a little bit closer to the 7. So we'd say it's about 7, but just don't forget about your negative sign here. If you want to throw negatives in here just so you keep track of it, good for you. But it's about a negative 7. Letter C. Now, 250, you don't have this one on your paper. So I know up to actually, this is about as high as I know. I know 15 times 15. Ooh, whoa, move him down. There we go. 15 times 15 is 255. No, 225. 225. Apparently I don't know it so well. And the square root of 16 is 256. That one I do know. Well, where is this plus or minus 250? Well, he's definitely closer to 16 than he is to 15. So we'd say this is about 16, plus or minus 16. Here's what I'd like you to do. For letter D, I would like you to pick a number that's not a perfect square, that's not part of this chart that you made on your note sheet. So pick a number in that range, and then try to find the approximation of it. So you come up with your own problem, I want you to do, and then try to find the answer. So let's say, for example, me, I'm going to use 45. That's not a perfect square. But I know the perfect squares around it are square root of 36 and the square root of 49. Square root of 36 is 6. Square root of 49 is 7. And so this one is closer to 49 than it is to 36, so I'm going to solve about 7. And there we go. So you look at the chart we made, the perfect squares and their square roots, and you see which numbers are closest to the number they give you. Then you just kind of estimate, well, in my letter D here, 45 was closer to 49 than it was to 36, so I said it's about 7. Please do letters E, F, G, and H right now. Pause the video, do them on your own, and we'll get back together here in just a minute. Okay, so let's see what you got. Square root of 30. Well, I know bigger than it is 36. Less than it is 25. That's 5. That's 6. I don't know. He's 5 away from here, 6 away from there. So it's a little bit closer to the 5. So we could just say it's about 5. If you said about like 5.5, that's still probably okay. Here, I pulled up a calculator. I'm curious what this would actually be. So 30 square root, 5.47. So it's a little bit closer to 5 than 6. But if you put 5.5, that would be horribly wrong. Okay, number 7, or letter, number 7. Letter F, 70. Bigger than that, we've got a square root of 81. So this is 9. So 864. We've got 6 away, 11 away. It's definitely closer to 8. And then just don't forget about your negative sign. Letter G. 8 is, well, we've got 9. And 2 would be square root of 4. And it's definitely closer to the 9. So we're going to say it's about 3. A, B, O, U, T, 3. And we'll put our plus or minus in there. You're looking at your perfect squares close to 8. The perfect squares close to 8 were 4 and 9, which was 2 and 3. And so the answer was about 3. Letter H, square root of negative 20. Now, I bet I fooled some of you, and I fooled you intentionally here. You guys probably said, okay, well, let's see. That's like square root of 16 is 4, and square root of 25 is 5, and so this is about a negative 4. If you said that, it's understandable why you would say that. But it's wrong, intentionally, and I want to show you why. Don't erase. I just want you to listen and look and understand why this is not true. Remember what square roots were. Perfect squares. To get this number on the inside, you take a number times by itself. Well, what number times by itself will give you something around negative 20? And if you go, well, negative 4 is close. What's negative 4 times negative 4? A positive 16. Positive 16 is not close to negative 20. Well, what about if you use like a positive 5? 5 times 5 is a positive 25. There's actually a rule in math that says you cannot take the square root of a negative number. The square root of a negative number does not exist. Because there's no number times by itself that will give you a negative. Let me come up with a more concrete example to explain this to you. So if I have the square root of negative 9. Now 9 is a perfect square. So you think, okay, well that's 3. Well, is 3 times 3 equal to negative 9? The answer is no. It doesn't work out. Well, what if you use a negative 3? Does that equal negative 9? The answer is no. Because the rule for multiplication of integers was if the signs are the same, you always get a positive number. So you literally cannot take the square root of a negative number. Okay? So this answer is no solution. You literally cannot take the square root of a negative number. Okay? So if there's a negative on the inside, you've got problems. Negatives on the outside, you're okay. You can do that. Okay? Here's a couple problems I'd like you to try on your own. These are from page 110, 111, numbers 1 through 8. The first 4 will actually have answers based off the chart we wrote down. The next 4 you're going to have to approximate. Okay? Go ahead, pause the video, do them on your own, and we'll get back together here in just a second. Okay, so let's see how you did. Negative 3, positive 5, plus or minus 8, negative 9. Did you get those correct? Those are all directly from your chart that you wrote up above. Yeah, up above here. I mean, 9 square root is 3. 9 square root is 3. Same thing with 81 and 9, 64, blah, blah, blah. Got them. Good. All right, down below we got a little bit more troubles. Take some more time. So, what perfect squares are around 32? You've got 25 and 36. This one gives you 5. That one gives you 6. 32 is closer to 6, so we say about 6. Number 6. Around 103, let me think, we've got 100 at 10, and bigger than 10 is 11 at 121, and 103 is definitely closer to 10. About 10. Number 7, let's see, 48. Well, I know 49 is a perfect square. And that's 7, so 6 would be 36, and negative, 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 negative. Definitely closer to negative 49, so I'm going to say about negative 7. And this last one, number 8, we do not have something up to 350. I think the biggest one we went up to was 169. So now we got to think a little bit harder on this one. So let's do some math. Well, I think earlier in the lesson, we did a 15 times 15, didn't we? Yeah, we did 15 times 15 is that. 16 times 16 is that. We need to get to 350. Well, 20 times 20 is 400. What's 19 times 19? 19 times 19, 9 times 9 is 81. Ooh, where the heck did I put my line down there? 81, 9 plus 8 is 17. Drop down, add a 0, 9 and 1. We got a 1, and 9 plus 7 is 16. Carry the 1 and 3. Oh, that's pretty close, though. So I bet it's going to be a 19 and an 18. That's 361. And what's 18 times 18? 18 and 18 is 64. 8 plus 4 is 14. And then 8 and 1 gives us a 4 and a 2 and a 3. Negative, 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 negative. So our answer, let's see, 350 is closer to the 361, so our answer is about negative 19. And you notice I had to do long multiplication because we don't have a calculator to use yet. So long multiplication to get my answer. All right. So we've seen perfect squares. We've seen approximating square roots. The next thing we're going to see is just classifying some numbers. So here I have the number square root of 38. And I want to be able to break that down. Is that thing real? Is it rational? Is it irrational? Integer, whole number. So it might help you if you put down yourself maybe a little note above. So whole number, like 1, 2, 3. Only positives, no fractions, no decimals. Integers, -2, -1, 0, 1, 2. Positives and negatives, whole numbers. No fractions, no decimals. We're going to jump over here to rational. A rational number are fractions. So if you can write the thing as a fraction, it's rational. Irrational means not that, not a fraction. And real is everything. Or I should say almost. As far as you're concerned, it's going to be everything. Every number you're going to see is a real number. Alright, so let's see. Square root of 38. Does that come out to a nice, pretty number? Is that one of our perfect squares? No. So we're going to say it is it a rational number? No. The only time we're going to get rational numbers from square roots are if it comes out to a nice, pretty number. Is it irrational? Well, yeah. If it's not rational, it's irrational. These two things are literally opposites of each other. Integer. No, it's not a whole number. Whole number? No, it's still not a whole number. Alright. -81. Real number? Yep. Rational. Can we take the square root of 81 and get a nice, pretty number? Yes. We get -9. So this is equal to -9, so yes, we can write that as a fraction. Is it irrational? No, because these two are opposites. Is it an integer, positive or negative? Yes. Is it a whole number, which are only positives? No. We'll do one more together. Square root of 16, and then I'll let you do the bottom two by yourself. So square root of 16, that thing equals +4. Is it real? Yes. Can you write 4 as a fraction? Yes. 4/1. Is it rational? No, because these are opposites. Is it an integer? Yes, because integers are both positives and negatives. Is it a whole number? Yes, because whole numbers are positives. Okay, I'm going to put down these bottom two rows. I'd like you to pause the video and fill in the chart as best you can. So you get a negative square root of 20 and a square root of 49. Go ahead, pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, you should be done, and let's see. Real, yeah. Rational. Well, square root of -20 does not come out to a nice even number, so it is not rational, which means it is irrational. Is it an integer? No, because it did not come out to a nice pretty number. Is it a whole number? No, because it did not come out to a nice pretty number. Square root of 49 is 7. Real number? Yes. Rational number? Yeah, we can write that as a fraction. 7/1. Irrational? Nope. Integer? Yep. Integers are positives and negatives. Whole number? Yep. So we've classified. Real numbers are pretty much everything. Rational numbers are anything you can write as a fraction. Irrational numbers literally mean not rational. So if it's not rational, it is irrational. Integers are positive and negative whole numbers, and whole numbers are just positive things without fractions or decimals. Okay? The next thing we're going to do is graph and order real numbers. Now, I'll be honest, I don't really like using this number line all that terribly much. I'd rather just find what these guys, approximate them as decimals if possible, and go from there. So let's see. Each of these we want to turn into a decimal. So 1/2 as a fraction, as a decimal is 0.5. That's one everybody should know. 3.5 is already a decimal. Square root of -4. Okay, so, or the negative square root of 4. The square root of 4 is 2, and the negative of that would be -2. Square root of 15. Well, that one does not come out perfectly. So we can estimate. Let's see. 15 is between 16 and 9. It's definitely closer to this, which was about 4. So we're going to call this, ready for this? Check out this ugly symbol. About 4. Actually, it's one squiggly. One squiggly, this means approximately 4. It's a little bit less, maybe like 3.9 or 3.8. If you want to do that, sure. 3 point something, like 9 or 8. It's really close to 4. Okay, now we can put these numbers in order. So we have them all as decimals. If you remember when we were doing this way back in lesson 2.1, the more negatives a number has, the smaller it is. So this is a negative 3.5 is the smallest, followed by -2. Now we're into positive land. Positive 0.5 is smaller than positive 3 point something. And probably the better way to write this would be back in the original form. So what do we have? Negative 3.5, negative square root of 4, 1/2, and square root of 15. So I wrote it back how it started. So we changed them all to decimals, ordered the decimals, and then just rewrote it back in the original form. Letter B. Let's see, decimals. Negative 1.6 is already a decimal. Square root of 8 is between square root of 9 and square root of 4. So it's, let's see, this is 2, this is 3. So it's almost 3. So I'm going to put almost 3. Negative, let's see, 2/3. That's one of those things you probably know off the top of your head. 0.6. And -2 is -2. Alright, so let's see. The most negative is this, negative 1.6. No, I lied. I didn't see that -2 out there. -2 is the most negative. Then negative 1.6. Then negative 0.6. Then the about 3. So we changed them all to decimals. We ordered. And then we're going to change back into the original form. So -2 was -2. Negative 1.6 was negative 1.6. 0.6 came from this -2/3. And about 3 was square root of 8. So that's the answer we were looking for. So change it to decimals, order the decimals, change it back into the original form. Here we go. I would like you to try these two problems. These are letters C and D. Make sure you can understand what we have written here. There we go. Do letters C and D. Pause the video. Do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, so let's see here. Decimals. Well, 12 is not a perfect square. Here. I'm going to erase letter A. I need that space. And B. I need that space. There. Alright, 12 is not a perfect square. It's between the 4 and the 9. Square root of 4, square root of 9. Which one is it closer to? It's about 8 away from here, about 3 away from there. So I'm going to call it a little bit closer to -3. So about -3. -3.7 is already a decimal. Square root of 9 does work out to just 3 and 2.9. Okay, so now let's see what we got here. We have them all as decimals in order. So the most negative is about 3.7. I'm sorry, yeah, it's this -3.7. Then the about -3, because those are the only two negatives. Followed, now we're getting bigger, 2.9, and then 3 is bigger. So we change them to decimals, we put them in order, change them back into the original form. So -3.7 was -3.7. Sweet. About -3 was this negative square root of 12. 2.9 was 2.9, and 3 was square root of 9. Letter D. Doesn't he look fun? Okay, so decimals. -11.5. This is a perfect square. That one actually works out. That is -11. And -10, 25 over 2. Well, to change that to a decimal, we would divide, or if you know what half of 25 is, because you're dividing by 2, that's what half means. Half of 25 is 12.5. And 144 is a perfect square, 12. Okay, so now we go and we put them in order. The smallest negative is -11.5, and then -11, and then -10. So those first three are actually already in order. And now in positive land, smaller. 12 or 12.5? Well, 12 is smaller than 12.5, so that's the order. So decimals, put them in order, change it back. -11.5, negative square root of 121, -10. Now we need this one, square root of 144, and 25 over 2. Alrighty. And lastly, example 5. Now it says we want to rewrite a conditional statement in if-then form. So here it says all real numbers are whole numbers. So we want to write that as an if-then. So basically the way this works out is you take the first part of the problem, all real numbers, you make it an if. Well, what if? So if a number is real, and the second part is the then. So if a number is real, then it is that thing. It is a whole number. So if a number is real, then it's a whole number. Now, I'm curious, is that thing true or false? So remember how we did these before. You look at the conditional statement, you come up with an example or two, and then see if it actually works out. So let me come up with a couple examples of real numbers. -3, pi, 2.6. So a real number was everything. So if a number is real, boom, 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 then it is a whole number. Are these whole numbers? No. This statement is false. Now we wrote it as a conditional statement, but it is a false statement because I found a couple examples where it was not true. Letter B. No fractions are irrational numbers. Okay, so if a number is a fraction, then it's not irrational. If a number is not a fraction, so no fractions are irrational numbers. So it's saying fractions are not irrational. Okay, so if a number is a fraction, so no fractions are irrational numbers. So if a number is a fraction, it means it's not irrational. Then it is not irrational. So let's see. If a number is a fraction, then it is not irrational. Is that true or false? So let's write a couple fractions. 1/2, 3/4, and a -2/9. So we have three fractions. If a number is a fraction, boom, 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 then it is not irrational. Well, these are not irrational numbers because they are fractions. The definition of irrational means you cannot write it as a fraction. So this is a true statement. If you could, please, I'm going to have you do letters C and D similarly. Write the sentences as an if-then statement, and then tell whether it's true or false. Go ahead, pause the video, do those two problems right now. When you're ready to continue, hit play, and we'll go through it together. All right, letter C. No irrational numbers are whole numbers. Okay, so if a number is irrational, then, so if it is this thing, it is not this thing. Then it is not a whole number. So let's see. If a number is irrational, then it is not a whole number. Well, let's see. Can we come up with an irrational number like pi or square root of 38? Just a square root that doesn't work out to a nice pretty number? Because we said all those things were irrational, right? Hey, we even use that example. Nice. So, if a number is irrational, it is not a whole number. Well, are these whole numbers? No, which makes this part true. This is a true statement. By definition, irrational numbers cannot be whole numbers. They are numbers you cannot write as fractions. And every whole number you could write as a fraction. Letter D. All whole numbers are integers. Okay, so if a number is this, then it is that. If a number is a whole number, then it is an integer. All right, so we wrote it out. If a number is a whole number, then it is an integer. Is that thing true? Well, let's come up with a couple examples of whole numbers. 1 and 9 and 47. Why not? Are each of those integers? An integer is any number, positive or negative, that does not have fractions or decimals. So the answer is yes. This is true because these three numbers are positive numbers, no fractions, no decimals. All right, last 4 problems of the day. This comes from page 112, 113, numbers 9 through 12 in the middle of the page. Go ahead and pause the video, do the problem. Well, I guess number 9's on page 112. The 10 through 12 is in the middle of page 113. Go ahead, pause the video, do these 4 problems right now, and then we'll get back together here in just a second, finish them up, check them up, and finish up the lesson. Okay, number 9. Tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. Then order the numbers from least to greatest. Okay, so I'm going to need some space. So first off, I'm going to write the numbers down. So -9/2, 5.20, square root of 7, 4.1, negative square root of 20. So it wants to know, are these numbers real, irrational, integer, whole number. So let's see. This, well, all of them are real. So all real. This number is, I'm trying to decide how to organize. I'm going to put my letters down here. So we're going to use R for rational, I for irrational, an N for integer, and a W for a whole number. So this negative 9 over 2 is rational because you can write it as a fraction. It is not irrational. It is not an integer because it's not a whole number. You can't have fractions, and it's not a whole number. So it's real and it's rational. 5.2. It is rational. You could write that as a fraction. That would be 52 over 100. Or not 52 over 100. 520 over 100. It is not irrational. It is not an integer. It is not a whole number. 0. It is rational, so it's not irrational. It is an integer, and it is a whole number. Square root of 7. It is not rational because that does not, the square root does not come out pretty. So it's not rational. It is irrational. It is not an integer. It is not a whole number. 4.1. It is rational. 410 over 100. Or 41 over 10 would also work. It is not irrational. It is not an integer. It is not a whole number. Negative square root of 20 is rational. That's equal to... Oh, no it's not. No it's not. Ah, big eraser. Square root of what? It was 20, right? Yeah. So it is not rational. It does not come out evenly. It makes it irrational. It is not an integer. It is not a whole number. Whew. Hope you got all that stuff down. So they were all real. Those guys were rational. Those two were irrational. Only that one was an integer, and only that one was a whole number. Now I'm going to erase this stuff to put my decimals to finish the problem. Alright, decimals. Half of 9 is negative 4.5, 5.2, 0. Square root of 7 is between square root of 4 and square root of 9, closer to 9, so I'm going to call it about 3. 4.1 and negative square root of 20. 20 is between 16 and 25. It's closer to that one, so I'm going to call it about a negative 4. So I changed them all to decimals. I'm going to put them in order. Let's see. The most negative would be negative 4.5, followed by negative about negative 4. Now we're 0, and then positives would be about 3, 4.1, 5.2. So decimals, put them in order, put it back in the original form. So negative 4.5 was this guy, so that's negative 9 over 2. About negative 4 was this negative square root of 20. 0 is 0. About 3 is square root of 7. 4.1 is 4.1, and 5.2 is 5.2. That was a pretty long problem. Alright. Can I move this stuff? How do we move it over there? There. Write the conditional statement in an if-then form, then tell whether the statement is true or false. If it is false, give a counterexample. So number 10. All square roots. So this thing, if it's this, then it's that. So all square roots of perfect squares. So if a number is a square root of a perfect square, then, let's see, all square roots of perfect squares are rational numbers. Then it is a rational number. All right, so let's see. Is that thing true or false? So if a number is a square root of a perfect square, so come up with examples of that. Square roots of perfect squares. Well, that's a perfect square, and that's a perfect square, and that's a perfect square. So if I take the square root of it, are those answers rational numbers? Can you write them as fractions? Absolutely you can. You could put that 7 over 1, 9 over 1, 5 over 1. So that is true. And that was number 10. I'm going to erase it to do number 11. 3, 2, 1. Number 11. All repeating decimals are irrational. Okay, so if a number is a repeating decimal, then it is an irrational number. So there's the if-then statement. Now let's go ahead and come up with examples. So if a number is a repeating decimal, so 0.11111, repeating. 0.123123, repeating. So if a number is a repeating decimal, then it is irrational. Are these numbers irrational? Now, we have to go way back up to our definition of irrational number. An irrational number are decimals that do not stop and do not repeat. Meaning, if you have a repeating decimal, it is not irrational. So repeating decimals, then it's rational? No. This is false. Irrational numbers cannot have a repeating pattern. Last problem of the day, number 12. No integers are irrational numbers. So if this, then not that. If a number is an integer, then it is not an irrational number. So let's see, if a number is an integer, so come up with some examples of integers. Get some negatives, get a 0 in there, get a positive. That's not a positive. What am I doing? Get a positive. Okay, so if a number is an integer, boom, 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 then it is not irrational. Are these guys not irrational? Meaning rational. Are these rational numbers? Yeah, I could write each of these as a fraction. True. Summary. How do you find the square roots of real numbers? So the majority of the lesson was talking about square roots. How do you find the square roots of real numbers? Go ahead, pause the video, write down your answer. I'll do the same. And there's my answer. I said if the number is a perfect square, you use the table of perfect squares to find the square root. So that chart that we made where we listed the squares and the perfect squares and their square roots. If the number is not a perfect square, then you approximate the square by looking at the perfect squares around that given number. Okay? And then homework comes from page 113 to 115. Numbers 3 through 39, multiples of 3, so that's 13 problems about. And then number 47, so it's about 14 problems for homework. Okay? This has been lesson 2.7. Thank you for watching.